Well, thank you very much. My name is Racquel Ros, and I'm going to present the work that we've been doing at Robotics with my colleagues Lorenzo and Emmanuel. And basically, thanks for that introduction and that need of different standards, because that's precisely what we're trying to do with the Ros for HRI, like trying to build on top of Ros framework and way of finding these interfaces between different models that can help us in developing our robots in social robot interaction. So, as we've been talking throughout the day, the motivation is basically on benchmarking and reproducibility in robot interaction. What are the causes? Why can't we get there yet? As I mentioned this morning, I think one of the big problems is that we're dealing in a very complex domain. As we all know, humans are very predictive. Everything changes. Even if you have the same thing, it's not going to work the same way every time. And so that's one thing that we have to just deal with, because that's where we want to work our robots to be working on. But the other thing is also about this lack of standards. And here's where Ros for HRI comes into play. So I don't know how familiar you are to that, if you ever heard about it. So basically, Ros for HRI was introduced in 2021 on FIROS, and now it has been accepted as a Red 55 Ros specification this year. Basically, it's a framework, it's a set of conventions that are kind of defining these interfaces, and it's thought for human-robot interaction scenarios. So it's very focused on the human in the loop, the human perception for now, through different modalities. But it can be it's a starting project, and then the aim is to grow it more with the community. It's obviously by the name is based on raw. Because most of us work with ROS, and we have research needs some more tools to be able to use ROS in a more efficient way, and just to forget about some things, and that's kind of set. And what's very also important, we have mentioned already as well this morning, is that is platform agnostic. So we don't really care whether we're working with this robot or that robot, and that's kind of the message that I want to convey today. I'm not going to talk about very technical stuff, because that's not, I'm more a user of the framework rather than a developer of the framework. But my colleagues can definitely help more on that if you want to know more. Basically, for me, the question was, why is it useful for me to use Ros for HRI? And there are two main things to start with when I'm building my prototypes, when I'm building my systems, is basically I want to have a way of testing different models. For instance, I have my face detector 1, face detector 2. I just want to see what is this better than the other one when I'm saying it, yes or no. And what's allowing me for HRI is that I don't really have to care much about the whole system or how this is done internally. As long as the inputs and the outputs of those models are standard, then whether I'm using this or that one, the rest of the system should be working the same way. So that's kind of already giving me some tools to be able to test and evaluate the system performance when I'm evaluating or developing some approaches for one thing or the other one. And as I already mentioned before, what is also very important for us is being able to use it in different platforms, no matter whether I'm working in this lab today and tomorrow I'm working somewhere else. I can just move, and I can make sure that my overall system is going to still work in the same conditions. So that's just a brief introduction of the talk today. So I'm going to, as I said before, I'm more of an end user rather than the developer of the framework. So we're going to go very quickly through the overview of what Ros for HRI can offer today. And then I'm also going to talk about some new developments that we're working now with. Recently, this past 3 months, basically 2 months ago, we started working with intents and how it can be useful for researchers in HRI. And then also some visualization tools, which is also something that's important when we are developing systems, not just about the development itself, but how can we actually analyze and understand what's going on in the system. So very briefly, Ros for HRI, since it's meant for human-robot interaction scenarios, then the main thing is starting like how can we model the human in the system. So for this, we have 4 different unique identifiers. The first 3 are non-persistent. That means that every time I can just detect a face, and then I can see that face gone and then appear again, and then I have a different ID. Doesn't really matter. So Things can come up and go, bodies, voices, for instance. These are the three main features that we are tackling for now. And then what we have is a person, which is this unique, and this is kind of an abstraction of what a human is, right? So the person is actually, so in this scenario over here, we have here a robot that is interacting with user A, for instance, and for user A, I can detect the face, I can detect the body. So then these are some ideas about this person, but this person ID is going to be fixed throughout the whole interaction. These ideas might change, but it's up to the person model to define, yes, every time I see a face, this face actually matches to this person. So this is the person that you're looking at this time. In this case, for instance, here we have person B, we cannot see the face, so there's no face ID, but we can see the body. So then the tracker gives me this information, and I can already create my person, number 45FA in this case. And the last one would be this case where the user is in the back, so there's no visual perception of the person. I can hear the voice, for instance. So again, just by having at least one of those IDs, I know that there's a person there, and then I'm conscious about, I'm aware of this presence in there. So different ways of playing and representing the human in the system. So this is basically what I just went through. So we have these different models in this case, and this the person vision is the one that's in charge of handling all this information and making sure that you're looking at this person, that you can identify that person, no matter which modality you're using to interact with them. Very quickly now, in terms also of the kinematic model, it's based on a URDF standard. Basically, in this case, the human body varies from one to another. So basically, we're taking the human height as the reference parameter, and then from there, based on the models, standard models of anthropometry, then we can then derive the rest of the body, the other dimensions of the rest of the body. Once a person is detected, then we can then assign a body ID, and then that's part of a new representation of the system. And then because we're using, again, a Ros URDF model for that, then we can just put that, and then the whole system can be aware of and work with this information. In terms of the specifications, basically the two main things that Ros for HRI is specifying is the topics and the messages. For the topics, again, we have related to faces, bodies, voices, and the persons, as we just mentioned before. These are the ones that we will be using throughout the system. And then we also have a special one, which is human interactions, which is the aim is that we can use also, we can kind of model group interactions. In this case, it's just not just one user, but there are multiple persons, and then there is some sort of group relationship between them, and then we also can get this information from them. And also very quickly now, we have also a bunch of Ros messages already defined. As you can, I won't go through all of them, but basically you can see that we have some audio features for the voice. Then we have everything related to body posture, to facial information that we can detect from the users. We also have gaze gestures. Well, you can see kind of already what we have defined so far that we find it's useful. But of course, this can be the data that we can continue contributing and then enlarging this as much as we need it. So that was a very quick overview of Ros for HRI as it is today, as it's been a specification. In the specification already accepted. That new thing that I just wanted to talk a little bit today is about the intents. And the intents is basically it's a first initial attempt. So please, as you can see, it's very new, and we're thinking whether this could actually help to developing the more on the side of the supervisor, of the controller of that system, right? How can we actually be very reactive as well to any input that is coming at any time, and then on that think, okay, maybe this controller is better than this other controller in terms of the supervision of the whole system. So basically, an intent is an abstract description of the operations that the robot has to perform at some point in time. It's inspired from the Android intents, and as we said, the idea is to capture this explicit or implicit intention of the user when it's interacting with the robot. So here we have three examples. In the first case, for instance, the user might touch if there's a screen, then the user is touching the screen, then you can infer that the intention of the user is to interact with the robot. So that would be a very explicit intent when the user is explicitly telling, I want to tell you something, like you can imagine that I'm tapping you to say, hey, I'm here. Of course, we can also have other type of intent that could come through other modalities. In this case, for instance, we could have voice. In this case, the user is talking to the robot, so then we can say, okay, the user is trying to engage with me in some way, or maybe just the user is saying something out loud, and from there I can infer that the user may want something. So it can be either explicit or implicit in this sense. And then finally, we can have the more implicit intents where basically I just can observe that the user is kind of approaching. So maybe the user is trying to talk to me at some point. So in this sense, as I was saying, the idea is that we somehow receive all these intents from either from the outer world or from the inner reasoning of the system itself, which are going to say, okay, hey, you have to, all this has to be done, or these intentions are being done. So it's up then to the supervisor, to the control of the system, to decide which one should be attended based on the resources of the system or priorities or whatever mechanism we would like. So idea for me is what, how can I build different managers of this application in terms of applying this approach, works this well. Now I'm applying this other approach and it's doing, and this is the behavior of the robot, so that I can easily compare given all the inputs, the intents that the system is receiving, how is that robot behaving in some circumstances or another. So quickly again, if we go through the specification of the intent as it is now, so what we have to define, of course, is what the intent is. There's data that you can have all kind of the parameters that are going to be related to that intent. What's the source of that intent, the modality, and then we can also optionally have like a priority, maybe something where we can also set that, and the confidence level. So just how sure I am about that intent. So very simple examples here. For instance, if the user says I want you to go to the kitchen, and it's a very clear intent here, from the human perspective, where I'm telling you go to the kitchen, right? So that the intent is being moved to in this case, for instance, and the goal in the data is basically go to the kitchen. That's where you want me to go. Another example could be like bring me, can you take the groceries to look in the kitchen? And the intent from here we can say, okay, the human wants that the robot brings the object, and then in the data we put all the parameters that I need to achieve such goal. And the last one, as we were showing before, like the user is less than 2 meters away and is looking at the robot. So from here I can infer that maybe the user wants to engage with me. So this intent will be triggered. And in that sense, we also have all the information that we really need to then process that intent, to execute an action according to that intent. And finally, just to also mention, as I said, it's not just about thinking of how to develop the system, but also how can we easily understand or analyze what's going on while the robot is performing. So here we have started also developing some simple visualization tools, but often are very useful when you're like trying to guess, okay, what the hell is a robot doing? I'm sure we have gone through all that experience very often. So 4 tools that I just wanted to present very briefly here. The first one is humans, which are, most of them are these plugins that we can use to, in this case, to visualize the human perception features that we have talked at the beginning about the faces, the bodies. So we have some examples over here. Then we have the skeletons 3D, basically as well to the visualization of the human model for multiple people in this case. So you can see here the video, there are different people, and you can see how we get that representation of the people in there. Then we also have TF for HRI, which is a reimplementation of the original TF tool. And basically is providing us human-related frames associated with the faces, with the bodies, the voices of persons, so the topics that I mentioned at the beginning of the talk. And finally, we also have this human radar. So this would be the one here. So it's basically clearly showing us which the person, that the people that the robot is detecting at every time, and it's like in this radar, so a line of where to localize where the humans are from the perspective of the robot in this case. So to conclude, basically, we are currently contributing to the Ros for HRI community in this sense. From PAL, we're very interested. Basically, we have our social robot Ari that's over here. Ari is being built up using this framework. We really believe that is a way of going into standardizing the practices and then being able to test, also because we have different robots to say anything that we're developing for Ari, can we also use it in other robots at the company or robots that are outside, of course, if they are based in Ros. Can we easily do this? Yes or no? Ari is our social robot that we've been using since in 2019. We've been using different projects, both European and national projects. And actually, we have a demo during these days. So if you are around, we'll be happy to hear your thoughts and see if you can come and chat with us. What's behind the system in Ari in this case? Basically, we have two main pipelines, which is the human perception on the one side, which is using everything is using the Ros for HRI framework for now. On the human perception, we have everything related to the vision, basically, and it's like how we can make our robot be more aware of the environment and become more alert and proactive when interacting with users. And then we are recently also working on the natural language processing pipeline. Basically, we're really playing with different existing systems. So for automatic speech recognition, for chatbots, dialogue management, etc. So it's not that we're developing, but we're using different approaches, and basically with our pipeline, we're trying to see which one is the one that's more suitable for different applications, what works best. And what we're going to do from now on, as I said, we're going to continue developing tools that really help us on the development of these standards and systems that can be easily used for everyone. In my case, I'm not a very techie person. I can use them, so I can say it's easy to use in a way. Hopefully documenting everything, which is also very especially important requirement, as we all know. We are building on the social capabilities of our robots and hoping that we can do much more than what we're doing so far. Especially, we also want to work more on the voice, on the voice input to the system, not just vision, which is kind of what we're doing, all of us, most of the time. And of course, we also want to engage with the community and try to see if you would like to also contribute to this project for HRI. And I think is a starting point. I don't know if it's going to be the framework for official for everybody, but at least it was something that we can grow together and be able to build more sustainable and shared systems throughout the community. Yeah, in case you want to have a look, then we'll go to our GitHub repository, Ros for HRI, the wiki documentation. And any feedback, you can also get it from there. And that would be it. And again, we're looking forward to see you in our booth in the following days. Thank you.
Questions? Yes.
The intents, are they learned or are they?
No, in this case, we're basically just providing kind of the tools so that you can use that. Then how you want to use them is really up to you. If you want to prefix them, then it's up to you. If you want to apply some learning on that. So it's not that we're proposing any algorithm on how to use them. It's more about here are the tools that you can use to be able to build your system, and then from there you can try anything you would like.
Are you familiar with other types of kind of tool sets like this that are being developed for HRI, at least at this scale?
No. No, I mean, there are other systems like also you can see in the reference that like one big system that it was kind of meant in this way from SoftBank, for instance, but it's not, but it's closed. It's not open source. And then a lot of things actually that were developed at the beginning for Ros for HRI were kind of inspired on the way that our framework works. But having, of course, this idea had to be open source, because otherwise we can't use it in all of our projects.
Well,
That's one of the main inspirations.
Victor has a question here. Are there some companies or institutions contributing to this awesome project?
Well, PAL is definitely into it. It didn't start at the PAL, but now it's, as some of you may know, so PAL is really always has been focused on the use of ROS and the open source. And that's why it's now also really hoping that people will be also working this. We do have some contributors in the GitHub. We have seen people going in, but not like a massive thing.
Gotcha. Okay. Very good. Thank you.
Thank you.